The Airbus A380 is a modern-day engineering marvel, the world's largest commercial wide-body passenger aircraft with a capacity of 400 to 550 passengers in a full-body double-decker configuration that can fly 14,800 kilometers non-stop. For example, Dallas, Texas to Sydney, Australia, or Dubai, United Arab Emirates to Auckland, New Zealand in a single non-stop flight. However, this aircraft had its fair share of problems before its first flight. One of the biggest troubles revolved around planning and coordination during the design phase that resulted in significant rework due to wire routing issues. In the late 1980s, based on internal studies and air travel forecast, the European multinational aerospace corporation, Airbus, began to study the feasibility of developing a new commercial wide-body aircraft to challenge the superiority of Boeing's flagship 747, which entered into service with Pan Am in 1970. Airbus finally launched the A380 program in December of 2000, built on the premise of hub-and-spoke methodology with smaller aircraft carrying people from smaller regional airports to larger hubs. Once at the larger hub, passengers would be consolidated on the larger aircraft to travel to other hub airports all around the world, and then again board smaller aircrafts to reach destinations near smaller regional airports. Not long after Airbus announced the launch of A380 program, Boeing initiated the 787 program, betting that the airline industry would shift to a point-to-point strategy instead of the hub-and-spoke strategy, allowing passengers to travel directly from their point of departure to the destination. Once the 787 program was underway, Airbus responded with the development of A350 to cater to the point-to-point market. Likewise, Boeing responded with a redesigned and extended upper deck of the 747 in the 747-8 program to compete with the A380. The initial cost estimate of the A380 program were projected to be 9.5 billion euros, with production of major components spread across 16 European countries, including France, Germany, Spain, and the United Kingdom, and as many as 30 suppliers worldwide, with the company leadership residing in France and Germany. With the extremely large sections of the aircraft being transported from dispersed manufacturing facilities around Europe to the final assembly location in Toulouse, France, new and innovative transportation systems were developed. Transportation of the components was accomplished via land, sea, and air. Navigating the tight streets of some European towns was one of the challenges that had to be overcome and needed to be considered in the design and the manufacturing process. Additionally, new roll-on, roll-off ships and barrages were required with the seaport modifications to facilitate transportation by sea, and finally, a specialized transport aircraft known as the A300-600ST Beluga was used to transport large components by air. Beyond the sheer size and capacity of the A380, Airbus introduced several new technologies in the development of A380. These technologies included new flight controls and architectures via dual hydraulic and electric system that allowed for a lighter and smaller hydraulic system to reduce weight and improve redundancy. Modular avionics to enhance capabilities for integrating new technologies. An onboard information system to create a paperless cockpit and improve connectivity. Introduction of a new generation of high bypass ratio engines that lowered noise and emissions. Improved aerodynamics to lower fuel burn, noise, and maximize field and climb performance. Step function change in reliability via variable frequency and electric power generation. Significant weight reduction through the use of advanced materials in specific area that also reduced the number of required inspections, and deployed the breakthrough VK technology that helped to reduce runway occupancy by as much as 30% by helping the pilots to pre-select the best exit runway. Breakdowns in communication, program cost, and delays are common in any project. But when dealing with a multinational organization like Airbus, these problems can be amplified and lead to a large disconnects. One such problem occurred during the final assembly of the first aircraft in 2004, After routing electrical cables through the fuselage, it was discovered the cables were too short and unable to follow the prescribed routes. The immediate consequence was that all the routed cables would need to be ripped out and rerouted to complete the first aircraft. The effort to fix the problem was monumental, as the first 3 aircrafts have to be completely rerouted with dozens of specialists flown in from all across the company at a substantial cost in labor, program delays, and eventually a significant cost to the company value. With the advent of product lifecycle management tools and processes to create, approve, track, and maintain all aspects of the design, manufacture, and supply chain, along with the benefits that maturing internet provided for companies to leverage interconnectedness, many companies overlooked the importance of ensuring system compatibility and process alignment. Although the A380 problem was identified during final assembly and stemmed from organizational and cultural issues, it physically manifested as a technology and a process issue. The German and the Spanish design team used an old version of the computer-aided design, or in short CAD, software known as CATIA version 4, while the design teams in France and the United Kingdom were using a newer CATIA version, version 5. The differences between these two software versions go well beyond the version number. CATIA version 4 was a Unix-based application, while CATIA version 5 was a Windows-based application, and version 4 did not hold the same design tolerances as version 5. Because of these differences, when the computer-aided design or CAD data was exchanged between the two systems, the conversions resulted in modifications to geometry which went unnoticed until the final assembly. If properly planned, compatibility problems could have been mitigated by either standardizing on a single design platform or using a standard digital mockup platform to ensure proper form, fit, and function, eliminating data translation issues. As a result of the design issues and other problems with A380, the total program cost approximately 19 billion euros, more than double the initial cost estimate, and over a year delay in the delivery of the first aircraft, which caused significant impact to the shareholder value. Singapore Airlines was the recipient of the first A380 in October of 2007, placing it in service in a route between Singapore and Sydney, Australia. As a result of the shifting markets and forecast, Airbus announced the end of A380 program in February of 2019, with the final production in late 2021. To date, 242 deliveries have been made out of the 251 orders.